My goal so far has been to show you the fundamental concepts of chatbot building and demonstrate to you how, by leveraging Watson Conversation, it's possible to build and deploy a simple but useful chatbot for your own website or business. If a florist client asked me to build a chatbot for them, I would of course spend much more time fleshing out the chatbot. I would make it stronger at handling chit-chat interactions, handle more occasions, relationships, and scenarios in general. My suggestion to you is to spend enough time to build a solid chatbot for your own site, and above all, to do extensive testing. Speaking of testing, so far we test the chatbot by giving the right answers to the chatbot. In this module, we'll test the chatbot by intentionally trying to make it fail, and then discuss strategies to solve those problems. Pay close attention to how I find these problems, by avoiding to give the answer that the chatbot expects. The goal of this type of testing is to collect shortcomings. We can then decide whether a fix is needed for a given failure, or if it's an edge case that we can live with. No chatbot is going to be able to handle every single interaction from a user, because despite Florent's cognitive capabilities, we have not built a replica of a human being. It can be argued that even a skilled human being could fail at handling some queries, though the resulting conversation will certainly be smoother. Without further ado, let's try to break our chatbot. We can start by asking for flower suggestions for an anniversary. And when asked the question on whether it's our anniversary, we can reply with, "Wait a second." Florence doesn't understand this phrase, so we're sent to the anything else node. Now, if we reply yes, thinking that we're addressing the existing question, the chatbot waves us goodbye. That's not really good, is it? This happens due to a couple of problems, or shortcomings, if you will. The smaller problem is that yes on its own is interpreted as a goodbye intent, which rudely concludes the conversation with the user, when the user didn't actually express the intent to leave. Yes, we could mark this response as having an irrelevant intent. We can do so for common cases that we come across, but we can't realistically mark every possible input as irrelevant. You may have noticed by now how Watson will quite often interpret simple, vague answers as having a generic intent such as greetings or goodbyes. This is because by default it tries to find the best match among the existing intents, even if its confidence level in the match is quite low. We also have a more complex problem. Our yes was correctly classified as a response type's positive entity value, which is good. But by the time we replied, we were too late. We were already outside of the anniversary children node list, so the yes was interpreted out of context, if you will, and treated as an independent answer and not as a follow-up reply. Essentially, the problem is caused by the fact that an entity is tied to the current user input, which in turn is tied to a certain position in the dialogue. In other words, the chatbot knows what to do with the information we collect in follow-up questions only within certain child nodes within the dialogue. If we get out of the position with an irrelevant reply like we did, our reply will be analyzed and evaluated as if it was a brand new utterance and not a reply. In short, we have a couple of problems. Let's proceed in order though, by first addressing the generic intent detection problem. The solution to this problem is accessing and using Watson's confidence level for a given intent. Let's start with a couple of examples of the problem. What time is it in Paris? And yes are both wrongly interpreted as having greetings and goodbyes intents, respectively. What we can do is create a node just below welcome and above all other nodes. Within it, we can check how confident Watson is that the given input matches the intent Watson is proposing. If the confidence level is low, we'll just jump to the anything else node to notify the user that we are assured about what they're asking. If the confidence level is higher than the threshold that we set, the condition will be false, and Watson will continue evaluating the other nodes as usual. This node will essentially act as a gatekeeper for situations in which Watson is not confident in the user intent. We create the node as usual. We give it a name such as an intent confidence check. For the condition, we can use intents, open square bracket, 0, closed square bracket, dot confidence less than 0.7. What this means is that we want to check the confidence level of the first intent in the list of detected intents for the current input. The number you see in between square brackets indicates the position of the intent that we want in the list of intents. Quite often the list will only have one intent, but it's possible to have more than one. It's at 0 rather than 1 because most programming languages start counting indexes at 0 rather than 1. This bit of code you see is Watson conversation spell notation, which also adopts at 0-based indexing. We want to do the jump if the confidence level is less than, say, 70%. So we're checking that the confidence level is below 0.7. You can experiment with this number for your own chatbot if you decide to implement a confidence checker node, like I did. Next, we'll specify that the jump should be towards the anything else node's response. As an alternative to a jump, we could have created this node as a parent node and placed all the other nodes before anything else as its children nodes. At this stage of the design, however, a jump is just more convenient. When we test again, what time is it in Paris, and yes, Watson recognizes the intent with low confidence, and therefore we jump to the anything else, and we're told that the chatbot didn't fully understand what we meant, which is good. As a sanity check, we can try I and by to ensure that they both still work. In this case, Watson's confidence level is high, of course, because those perfectly match the intent of greeting and goodbye, so we get the right response as usual. This change also helps us with our second problem. Let's see how. I'm going to recreate the same scenario as before. Anniversary request, wait a second intermission, and yes as a late answer. Something is different this time. Instead of having the chatbot tell us goodbye, we hit the anything else node because of that gatekeeper node that we created. At this point, the user might be slightly frustrated, but they will understand that the yes was not understood by the chatbot. So they might try to ask the question again, and this time reply yes at the right time. It's not perfect, but it's more user-friendly than cutting the conversation short, like we did before. Our fundamental shortcoming remains, however. One irrelevant reply from the user and we move out of the follow-up nodes, at which point even a second correct answer will be interpreted as a standalone question and not a reply to a specific question. This problem can be solved by using context variables, which allow us to store and access information during the lifespan of a conversation with the user. So if we assign an entity value to a context variable, we'll know what the value is at any point during the conversation. This permits the creation of chatbots that are more flexible and much more aware of what information has been already collected so far from the user. In turn, this enables the bot to skip certain questions if the information has already been collected. In general, context is a very powerful way to preserve state in our chatbots. Slots are a new concept, only recently introduced in Watson Conversation. They leverage context variables, and though they are not strictly necessary, they make our lives so much easier and provide an elegant solution to this second problem of irrelevant replies. In the next video, we will focus on context variables and slots. I'm confident that after learning how to use them, you'll find them extremely useful in the creation of your own chatbots.